All right, we're still in section 3.2 here, so I'll get back to this worksheet, or I'll begin this worksheet. So we're going to talk about quadratic functions and then some more applications, some more story problems type thing. It says that a quadratic function is a function in the form f of x equals ax squared plus bx plus c. A, b, and c are any real numbers, and a can't be 0. Okay. In this section, we're going to look at two methods for graphing a quadratic function. The domain of any quadratic function is always all real numbers. Okay, now when I talk about a quadratic function, I'm talking about graphing a parabola. Okay, so that's the kind of curve that we'll be drawing here, is a parabola. Now there's two methods for drawing a quadratic that are common. One is just to use a list of steps, and then the other is to use what we know about transformations. Okay, and I'll talk about both of them here. So using a list of steps, we'll just use these 4 steps here to draw a parabola. It says, so step 1, we want to check if the parabola opens up or down. We're going to know that immediately just by knowing the a value. Okay, if a is a positive number, the parabola is going to open up. And if the a value is a negative number, the parabola is going to open down. Okay. The vertex, v, is always the highest or the lowest point on the parabola. V is given by the point negative b over 2a and then f of negative b over 2a. Okay. So that's step 2. Step 3 is where we'll find all the intercepts, and then step 4 is where we'll plot more points if it's necessary to. Most of the time it's not going to be necessary to do that. But and then we'll sketch the graph. Okay. So let's see, problem 1. So these first 3 problems are we're going to graph the function using the 4 steps that are given above. Okay, so problem 1, we want to graph f of x equal x squared plus 2x minus 3. So step 1, this parabola is going to open up because the a value is 1. 1's a positive number, and so I know the parabola is going to open up. Okay, step 2 is to find the vertex. So the vertex in this case is going to be the lowest point on the parabola. Okay, the vertex, negative b over 2a. So a is 1, we already said that, and b is 2. So I need the opposite of b, that's negative 2, divided by 2a, 2 times 1 is 2. Negative 2 over 2 is negative 1, and then f of negative 1. So when I plug in negative 1 in for x, negative 1 squared is 1, minus 2 is negative 1, minus 3 is negative 4. Okay, so this point here, negative 1, negative 4, that's going to be the lowest point on the graph. Step 3 is to compute the intercepts. So we got to get the x-intercepts and the y-intercepts. To get the x-intercepts, you need to let y be 0, or let the function be 0 and solve for x. And to get the y-intercepts, we need to let x be 0 and solve for y. Okay, so when I let the function be 0, I have the equation x squared plus 2x minus 3 equals 0. That's a quadratic equation there, right? The first thing I always think of when I'm solving a quadratic is if it factors. Okay, this one will factor. So we have x and x. The factors of 3 are 3 and 1. And that's going to be a plus 3 and a minus 1. So if I check that, x times x is x squared. Negative x plus 2x is, negative x plus 3x is 2x in the middle. And then 3 times negative 1 is negative 3 at the end. Yeah, that was good. So when I then set each factor equal to 0, x plus 3 equals 0 means that x is negative 3. X minus 1 equals 0 means that x is 1. To get the y-intercepts then, I need to let x be 0. So if x is 0, I'm just plugging 0 into the function there. And I get negative 3. Okay, so there's going to be 3 intercepts on this graph. They would be at the points negative 3, 0, 1, 0. And then when x is 0, y is negative 3. Okay, so I'll go ahead and plot those 3 points there. There's negative 3, 0. Here's 1, 0, and then 0, negative 3. So I got these 4 points there. And now I can draw a parabola as best I can. Okay. Make it so that there's a nice smooth turn through the vertex, no sharp turns at all. Okay, if you're drawing a graph that is a sharp turn, you're doing something with absolute value bars. We don't have any absolute value bars at all in anything with this. Okay, so we want a nice smooth turn through the vertex. And also, one of the features of a parabola is that it's got to look the same on either side of the vertex. Okay, so we don't want to draw, this parabola and have one side, flaring way out like something like this. I sometimes see that on students' papers. Don't do that. Okay, so it should be the case that if I spin the graph about the vertex, I'll get the same picture. Okay. Problem 2, I want to graph the function f of x equals negative 3x squared plus 6x plus 1. So a is negative 3. In negative 3, that's a negative number, so I know that the parabola is going to open down in this case. To find the vertex, I'm going to find the highest point on the parabola. The vertex is negative b over 2a, so negative 6 over 2 times a, 2 times negative 3 is negative 6. Negative 6 over negative 6 is 1. And then f of 1, so when I plug 1 into the function there, I have negative 3 plus 6, that's 3, plus 1 is 4. Okay, so there's the point 1, 4 on the graph, and that's the highest point on the parabola. The next thing would be to get the intercepts. So here's the x-intercepts and the y-intercepts. When I set the function to be 0 to get the x-intercepts, I need to solve the equation negative 3x squared plus 6x plus 1 equals 0. Okay, that equation won't factor no matter what I try for the factors, right? Because the factors of negative 3 are 1 and negative 3. The factors of 1 are 1 and 1. No matter how I swing that, I'm not going to get a 6 in the middle. Okay, so factoring is not going to work here. If we use the quadratic formula, the opposite of b is negative 6 plus or minus the square root of b squared. 6 squared is 36 minus 4 times a is negative 3 times c is 1. Okay, and if I take 36 b plus 12, or minus a negative 12, 36 plus 12 is 48. Okay, divided by 2a, 2 times negative 3 is negative 6 in the denominator. Now, root 48 breaks down, but I don't think that really much matters because we're going to have to make a graph of this. So I have to know where on this graph I'm going to be plotting these points. Okay, so if I type in negative 6 plus the square root of 48 all over negative 6, I get negative 0.15. And if I type in negative 6 minus the square root of 48 all over negative 6, I get 2.15. Okay, so here's negative 0.150 and then 2.150. And then if x is 0, to get the y-intercepts, I get 1. Okay, so 0, 1 would be on the graph. Okay, now with those 4 points, here's the vertex, and here's the 3 intercepts, I can then draw a parabola as best I can there. Okay, again, nice smooth turn through the vertex, and try to make it look like it's the same on either side of the vertex there. Okay. Here's another one. So what if I had the function f of x equals 3x squared minus 3x plus 2? Okay, that would be a parabola. And this parabola is going to open up because the a value is 3. To find the vertex then, which would be the lowest point, I take negative b over 2a. So The opposite of negative 3 is 3. Divided by 2a, 2 times 3 is 6. 3 over 6 is 1/2. Now, if I plug in 1/2 in for x right here, I should get 5/4 in return. Okay, so 1/2, 5/4, that's going to be the lowest point on this parabola. That'd be the vertex. Okay, and then to get the x-intercepts, I need to set y to be 0. When I let y be 0, I need to solve this equation here. This equation won't factor nicely for me. The factors of 3 are 1 and 3. The factors of 2 are 1 and 2. No matter how I swing that, I'm not going to get a negative 3 in the middle. Okay, so if we use the quadratic formula, the opposite of b is 3, plus or minus the square root of b squared, negative 3 squared is 9, minus 4 times a is 3, times c is 2. Okay, so I'm looking at 9 minus 24, that's negative 15 underneath the radical there. Okay, and this is all over 2a, 2 times 3 is 6 in the denominator. Okay, the square root of a negative, that's something that we're going to talk about a little bit later on in this chapter. Okay, not yet though, but it's in section 3.6. So the square root of a negative, that's not a real number. Okay, which means that there's not going to be any x-intercepts. By the way, I could have already known that before I did this. Okay, like if I know that the vertex is at this point 1/2, 5/4, and I also know that the parabola is opening upward, and this vertex is the lowest point on the graph, it's not possible for the parabola to cross the x-axis, right? So, you know, I could have known that before I calculated anything here. Now, a parabola will always have a y-intercept. Okay, so if I plug in 0, I get 2. Okay, so 0, 2 would be on the graph. Okay, now again, one of the things about a parabola is that it's got to look the same on either side of the vertex. So because 0, 2 is on the graph, it should be the case that 1, 2 is on the graph. And let me check that. If x is 1, 3 minus 3 is 0, plus 2 is 2. Okay, so 1, 2, that point would be on the graph also. And then using these 3 points here, I can then draw on the parabola as best I can there. Okay, so that's the first method for graphing a parabola, you know, where you're just following a list of steps here. And the second method is to use what we know about transformations. Okay, we talked about transformations in chapter 1. We'll get back to that, and I'll start in on that and then on the next video there. Okay.